Common factors. Next lesson here, starting off this next unit about factoring. We're going to use that F word quite a bit during this unit, so we should first figure out what are factors. What is a factor? And factors are numbers that, when multiplied, give another number. They're just numbers that multiply together to give another number. That's exactly what I said. Or two numbers that, when you times them, they give you a certain number. So, for example, if I said, what are the factors of 10? I'm saying, what numbers do you know that, when multiplied, give you 10? Or, another way of putting it, what are the numbers that can go into 10? So, think of it this way. You have what I would do is start with 1, write down 1, because 1 can be multiplied to give you any number at all, except for 0, and go to the number that we're talking about, 10. So kind of leave some space in between 1, which we know goes into any number, and the number 10, which, of course, the number we're talking about always goes into itself. All right, and just go up the number line, I guess. Does 2 go into 10? Yes, it does. Does 3 go into 10? Nope. Does 4? Nope. Does 5? Yes, it does. 5 goes into 10. Does 6? Nope. Does 7? Nope. Does 8? No. Does 9? No. Does 10? Yes, it does. So these are the factors of 10. 1, 2, 5, and 10. What are the factors of 12? So again, write down 1, leave some space, put down the number we're talking about, 12, and just think, all right, what are the numbers that go into 12? 1 does for sure. Does 2? Of course it does. Every even number, like 10 and 12, 2 goes into it. So 2 is always a factor of even numbers. So 2 is a factor for half the numbers in the universe. 2. About 3. Does 3 go into 12? Yes, it does. Does 4 go into 12? Yes, it does. Does 5? No. Does 6? Yes. 7, 8, 9, 10, 11, 12. There are your factors of 12. So I'm realizing I probably didn't need that much space between them, but I betcha I need a lot of space for this one. The factors of 64. Put down 1, leave some space, and leave some more space because it's a bigger number. 64. What are the numbers that go into 64? Well, it's even, so I know that 2 goes in there. Does 3 go in there? It doesn't. There actually is a trick to let you know how to know if a number goes into 3. If you add the two numbers up, and if it goes into 3, the sum of the two numbers go into 3, then it is 3 is a factor of it. 6 plus 4 is 10. 3 doesn't go into 10. Let's try it up here. 1 plus 2 is 3. Does 3 go into 3? Yes, it does. So you add the two numbers up, or 3 numbers up, and if those numbers, which will be smaller than the one you're talking about, if they go into 3, then you know that that number goes into 3. So anyways, little trick that might come in handy. So 3 does not work. Does 4 work? 4 does work. Just think 40 works, and 64 minus 40 is 24, and 4 goes into 24. So yeah, it does. Does 5? No. To know, remember, 5s always end in 0 or 5. 6 will not work, because we know that 6 times 10 is 60, and 64 is just not going to work. 7 is not going to work. 8 works. And 9, 10, 11 does. So then from here we realize that it's 16 that goes into it, and also 32 goes into 64. Those are the factors of 64. If you had a times table grid, you could, if you're not getting where I'm getting these numbers from, you're allowed to use the times table grid, and from there you can sort of see a pattern and see what numbers go into 64. Just look for 64 and see what column it's under on your times table grid, and if it's on that column, that means it will go into it. Now, what are the factors of 3x? The factors of 3x. Well, first off, what we're going to do is treat the 3 and the x separately. We know that 1 and 3. Does 2 go into 3? No. So these are the only two factors of 3. X. What is x? Well, how many x's are there? There's just one. So x is another factor. So what are the factors of 3x? I guess we can put them all together. 1, 3, and x. Now, if you're a little confused by the x there, maybe this next example will help you with that. What are the factors of 9x squared? Well, what are the factors of 9? Because we treat the numbers and the variables separately. 9 has, let's draw it out, 1 and 9. And you should know that 1, 2 is not going to work. 3 will work. 4 will not work. 5, 6, 7, 8, 9. So 1, 3, and 9 work for that. And what is x squared made up of? It goes into x squared. Well, an x does, and an x does. And that's it. Because there's two x's. So that's how you handle variables and trying to find their factors. X squared is made up of x times x. What about the factors of 4x cubed? Well, what are the factors of 4? 4 is made up of 1, 2, and 4. And you have 3 x's here. So you're going to multiply, to get 3 x's, you have 3 x's. X, x, and x. Those are the factors of 4x plus 3. How about the factors of this? 6x squared y cubed. Well, what are the factors of 6? 1, 2, 3, 6. And x squared is made up of x times x. And y cubed is made of y times y times y. There are your factors of 6x squared y cubed. There you go. Building up here. What about GCF, greatest common factor? Now, in a previous video in Math 8, I showed you one way to do this with a factor tree. I'm going to show you just by writing out the common factors how to do this. So if you have the number 10, you write out the factors of 10, which are 1, 2, 5, and 10. Write out the factors of 12 underneath. So 12's factors are 1, 2, 3, 4, 6, and 12. Now, which is the largest number that they both have in common? So start from this end and kind of play Go Fish. Is a 12 in this line? No. The 12 says, do you have a 6? No. Do you have a 4? No. Do you got a 3? No. Do you got a 2? Yes. You share a 2 in common. So the greatest common factor between 10 and 12 is the number 2. Okay, so this greatest common factor thing comes in handy next lesson. This is why we're going over it. 12 and 48. 12, we just saw up here, has these factors. 1, 2, 3, 4, 6, 12. 48 has the factors 1, 2, 3, 4, 6, 8, 12, 16, 24, 48. Now, if you're wondering how to get those numbers, is look at your times table grid or just work it out. Trust me, you'll get those numbers. And which is the greatest number they have in common? Start with the biggest number. Well, actually, you can start right here. Obviously, these numbers are bigger, are not even on the scene there. So what's the biggest number they both have in common? 12. 12, that's the biggest one they have in common. They do have other ones in common, but I'm asking for what is the greatest factor they have in common. So the biggest number they have in common, or the greatest common factor, is, in this case, 12. Now, some of you may have already known that, and some of you don't even need to do all this stuff. You just realize 12 goes into 48, and that's as high as we can go. Plus, another thing you can do. with all of these, just look at whatever the smaller number is and see, does that go into the bigger number? If yes, then that's your greatest common factor. If no, then you're going to have to figure it out. Here, we know that 12 goes into 48. Can't go past 12, so that's your answer, 12. 64 and 35. So let's think this way. Again, the smaller number. Does the smaller number, 35, go into 64? It doesn't. So we're going to have to do some detective work here. So for 64, 35. 64 we did above. For 64, it's 1, 2, 4, 6, 8, 16, 32, 64. For 35, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 35. What's the biggest number they have in common? Let's start with the 35. Nope. 7. Nope. 5. Nope. That's all they have in common, just the 1. So I guess the GCF in this case is 1, or really, they don't really have a greatest common factor. So you can say 1, which every single pair of numbers all share 1 in common as one of their factors, but in this case, 35 and 64, they have nothing that go into each other. They have nothing in common. Okay, remember the x's from above. What if you had 5x and 10x? What are the factors of 5x and 10x? Well, remember for 5, it's 1 and 5, and you've got 1x left behind. 10x, the factors are 1, 2, 5, 10, and there's 1x left behind. Okay, now we treat the numbers and the x's separately, and actually what I should do is maybe put the x's in their separate little section over here. So as the numbers, what's the biggest number that we have in common here? And just always think, well, 5, can the smaller number go into the bigger number? And if that's the case, then yes, that is guaranteed your GCF. So 5, and do we have an x? What do we have in common with the x's? It's variables. Well, we got 1x in common. So in this case, the greatest common factor is 5x. They both have a 5, and they both have an x. Okay, now 6x squared and 4x. 6 is made up of the numbers 1, 2, 3, 6. And x squared is made up of the variables, we'll do it separately over here, x and x. There's 2 x's there. Let's compare that with 4. 4 is made up of 1, 2, and 4. And how many x's do we have? Just 1. What's in common? Does 4 go into 6? No. 2, that looks like the winner there. So 2. What do they have in common with x's? 6x squared has 2 x's, the 4x only has the 1, so they both at least have 1x. So the GCF, or greatest common factor of these two, is 2 and x. They both have at least a 2, and they both have at least an x. Done. This one here, not actually probably is an easier one than the ones above. 2x and 8. What is 2 made of? Well, 2 is made of 1 and 2, and it's got an x. 8 is made of 1, 2, 4, and 8, and doesn't have an x. What's the biggest number that they both have in common? It's 2. They don't have an x in common. The 2x had an 8, but the 8 didn't. So the GCF in this case is just 2. Now if you're thinking, I don't need to write all this stuff out, what am I going to do this? I just realized I know that 2 is in common with the 8 and there's no x. And if you know this in your head, that the answer is 2, good for you. Okay, here. We got 3 terms. We got 36x squared. We got 12x. And we got negative 6. What is 36 made of? 1, 2, 3. Remember the trick for 3s, you add the 2 numbers up. 3 plus 6 is 9. 3 goes into 9, so it works. It's a pretty cool trick, actually. 4, yes. 5, 6, yes. 7, 8, 9, yes. 10, 11, we know that 12 times 3 gives you that. And we know that 18 times 2 gives you 36, and that's it. So let's separate them out from the variables. We have two x's. 12x is made of 1, 2, 3, 4, 6, and 12. And it's got 1x it can add to the party. Negative 6, we'll just leave the negative out for a bit. You've got 1, 2, 3, and 6 that are in common. If you want, you can actually do a separate column here and say that, so you have numbers, you have variables, and then you got signs. Well, technically, these two have a positive in common and a positive in common. This has a negative. So here we have to say what's common to all three. What's the biggest number that all three have in common? And so the easiest thing to do is just look at the smallest number, 6, and do they all have a 6 in common? Yes, they do. So 6 is your greatest common factor. What about the variables? You got it. Well, because there's no x here, yeah, these two have at least one x in common, but there's not an x here, so the x's aren't going to work. And the three do not share the same sign, so all we can say is that the greatest common factor in this case is 6. Now, what about this one? Negative 5b. Negative 15b squared. Let's take a look at the numbers. What are the factors of 5? 1 and 5. What are the factors of 15? 1, 3, 5, 15. That's it for the numbers. Let's look at the letters. We got 1b, b. We got 2 b's, b squared, b, b. Now let's look at the signs. We got a negative, and we also have a negative. So what do we got in common between the two? Got a 5 in common, that's the biggest number. We got at least one b in common, that's all we can say. And they both have a negative sign. So the greatest common factor is a negative, 5, and 1b. Negative 5b. How about this? What are the common factors of 8? 8 is made up of 1, 2, 4, 8. And it's got 2 x's, and it's got 3 y's. 10 is made up of, actually we should actually separate out the x's from the y's from each other as well. So like terms are in the same grouping, and unlike terms are in separate little groupings. So 10 is made up of 1, 2, 5, and 10. It's ugly looking, but it's 10, trust me. How many x's? We got 3. 1, 2, 3. How many y's? We got 1. Alright, what do we got in common? The biggest thing we have in common is 2. X's. We got one thing, at least one x. Actually, they have 2 x's in common, at least. They both at least have 2 x's. But because 10 only has 1 y, there's only 1 y in common. So what does this all become? The greatest common factor in this case is 2. And there's an x and another x multiplying each other. That's x squared and a y. Now, doing these in your head might be a little bit easier. You think, okay, you know that 2 is the biggest number that goes into those two numbers. Between x squared and x to the 3, we know that this has 2 x's, that has 3 x's. Well, they both at least have 2, so we know that that's that. This has 3 y's, that has 1 y. Well, they both at least have 1 y, so there's your answer there. So you can do all this, or you can just do it in your head and skip the step and jump right to there. Try doing these in your head. What do you know about 15 and 12? What's the biggest number that goes in 15 and 12? You could write out the factors and do the circling thing, but hopefully you realize that 15 and 12, the biggest number that goes into them is 3. So that's your GCF there. How about here? separate the numbers from the variables. What's the biggest number that goes into 4 and 20? Well, 4 does. They both have x's. This only has the 1x. This has 2, but they at least have 1x, both of them. So 4x is their common factor. And then over here, 18 and 10, what's the biggest number they both have in common? When you do some thinking, you realize it's 2. Let's look at the x's. We got 3 x's here, 2 x's there, so they both at least have 2 x's. And here we got 4 y's, 5 y's. They both have at least 4 y's. And that's your answer. Alright, so common factors. This comes in handy later on, and here are the skill testing questions that you'll need. Enjoy, bye-bye.